In this example, we have our f of x equals to 1 over x. So this is a function f, and we have a g of x equals to x square minus 1. Okay, we have a g function. We are asked to find, what is this? How do we read this? F composite g. Okay, this is not f times g, this is f composite g. This is G composite F. So in number A, we are asked to find F composite G. Okay, so this is a function. So let me write down its input. Its input will be x. Okay, we have a x as an input for a function f and x as an input for function g, and F composite G will have a x as an input. And the definition of this F composite G is F of G of X. Okay, you replace your composite sign by parenthesis and you get the definition. Okay, now after this it's gonna be substitution. So here we will substitute our G of X. What is G of X given to us? X square minus 1. So we have F as it is. For G of X, we substitute x square minus 1. Okay. Next, we need to find f of x square minus 1. Now, in order to find f of x square minus 1, we take a function f. Okay. We take a function f and we replace x of a function f by this expression. Okay, so we have 1 in the numerator as it is. In the denominator of a function f, we have x, and we replace that x by whatever expression we have in this parenthesis, that is x square minus 1. And this is f composite G. Okay. The next we are asked to find the domain for this function. So let's find the domain of f composite G. Now what kind of function is f composite G? So our f composite G is equals to 1 over x square minus 1. And what is the type of this function? Is it linear function? Is it quadratic function, square root function, rational function, absolute value function? What kind of function is f composite G? I'm sorry? So here, so our g of x is x square minus 1, right? And this is what we have as a input, and we replace our x of a function f by this. So we have 1 as it is, and in the denominator, instead of x, we will write from this expression. Okay, so here, so this is our f composite G. What type of function is this? Is it linear, quadratic, square root, absolute value, rational? This is a fraction, right? We have our input in the denominator. So this is a rational function. Now let's find the domain. Now if we have a rational function, to find the domain, how do we find the domain? At first, we look for a number which make denominator equals to 0. Now, can you tell me the numbers that make a denominator of this f composite G function equals to 0? So for what x value our denominator is equals to 0? Or we don't have any those number which make our denominator equals to 0? That's right. So if we replace our x by positive 1, we get 1 square minus 1, that is 0. In the similar way, if we replace our x by negative 1, we have 0 in the denominator. And 1 over 0 is undefined. It means 1 and negative 1 are not the domain. But every other number are the domain for this function. Okay. Now how do we write down that in interval notation? So we have negative infinity to positive infinity. Negative 1 and positive 1. These two are not domain. So we are excluding. But every number on the left of -1, every number in between -1, +1, and every number on the right of +1 are the domain for this function. So that is from -infinity to -1, union from -1 to 1, union 1 to infinity. Okay, so every time if you have a rational function, at first you find a number which make denominator equals to 0, and those number are not the domain. Okay, but every number other than those numbers will be the domain for a rational function. Any question for this part A? Now let's go ahead and do number B. In number B, we are asked to find G composite F. Okay, so which is same as G composite of X. Now what is the definition? So we have G as it is. For the composite we replace by parenthesis F of X. Okay, so this is the definition. So now we make a substitution. So we substitute F of X first. So we have G as it is. What is our F of X? It is 1 over X. So G of 1 over X. Now the next we have to find G of 1 over X. Now to find this, we take a G function. Okay, we take a G function, and for every X in a G function, we will replace it by 1 over X. Okay, so here we have X square. Now for that X, you will write down 1 over X. So we have 1 over X. X has a square, so this must have a square minus 1. Okay, and this is G composite F. We can still simplify this. 1 square is 1, X square is X square, -1. So 1 over X square minus 1 is a G composite F. It's a substitution. Okay, now next we are asked to find the domain of G composite F. Now what type of function is G composite F? What kind of function? Is it rational? Is G composite F a rational function? Where do we have our input? Do we have our input X in the denominator? We do have, right? So in the first term, so here, so in this term, in the denominator we have our input X. Okay, and every time if you have your input X in the denominator, it is a rational function. That's the easiest way to know. Now in order to find the domain for this function, we find a number that make denominator equals to 0. Now for what X value this expression is 0? For what X value we have our denominator 0 here? Can you think of a number that make X square equals to 0? Whose square is 0? Square of 1 is 1. Square of -1 is +1. But we want the square of some number to be 0. It has to be 0, right? So the square of 0 is 0. It means 0 is not a domain, but every other number are the domain. So let's write down that in an interval notation. We draw a number line. So from -infinity to +infinity, 0 is not a domain. So let's exclude it. So it means open circle. But every number on the left of 0, every number on the right of 0 are the domain for this function. It means our domain is from -infinity to 0, parenthesis, union from 0 to +infinity. Okay, so every time if you have a rational function, at first find the number that make denominator equals to 0, and those number are not the domain. Okay, but every other number are domain. Okay, any question here? Okay, now let's go ahead and start our next example. The cost of fuel for running a fleet of vehicles owned by Global X Corporation is given by C of X equals to 2.5x. So here we have C of X, and this C of X is cost of fuel. Okay, C of X is cost of fuel, and that cost of fuel is equals to 2.5x. Here our X is the total number of gallons. Okay, X is number of gallons of fuel. Okay, gallons of fuel used. So this is our C of X. So C of X give us the cost of fuel. Okay, if you want to find a cost of a fuel for running a vehicle, then this function give us. So here X is a total number of gallons of fuel used. The Canadian branch, however, record its fuel consumption in liters. Okay, the conversion from liters to gallon is given by this function. Okay, so if you want to convert liters to gallon, then we use this function. So we have G of X, and this is this give us the conversion from liter to gallon, and this is equals to 0.26x, and our X is the number of liters. So this is what is given to us. So we have two function. We have a C of X function, we have a G of X function. Okay, and these two functions represent, C of X represent cost, G of X give us, it helps us to convert liter into gallons. Now we are asked to find, now what is this? So what is this? What we are asked to find? This is, we are asked to find C composite G. So we are asked to find C composite G. So the definition is, you just write down C, replace composite by parentheses, then G of X. Okay, now let's do substitution. So we have a C as it is. Now we know what is G of X, and G of X is 0.26x. So 0.26x. Okay, now how do we find C of 0.26x? For this we take a C function. So our C function is here, and replace X of a C function by this expression. Okay, so in the C function we have 2.5 time, you replace this X by 0.26x. Now can you help me here? What is 2.5 times 0.26? 2.5 times 0.26. 0.65. Thank you. 0.65x. So our C composite G of X is equals to 0.65x. Okay, now here what is this X? So let's see. So we have this X from G of X, which is number of liters. So this X is a number of liters. Okay, now what does this expression give us? Now what does it mean for us? So our C composite G of X is 0.65x. Okay, so here if we are asked to find cost of running a vehicle, and if the total number of gallons of fuel used is 10, so what will be the cost of running vehicle? So we have 10 gallon of fuel. Okay, now what will be a cost of running vehicle with 10 gallon of fuel. Which function do we use here? C of x, right? Because C of x give us the cost. Now what will be that cost? You just replace, our number of gallon is 10, right? So our x is 10. So 2.5 times 10, that is $25. So its cost has to be dollar. Okay, is yes, $25. Okay. Now, so that's given by our C of x function. Now, if we want to convert, okay, let's say 10 liter of fuel into a gallon, which function do we use here? So we have a 10 liter of fuel, but we want to convert that 10 liter into gallon. Now, which function do we use here? So we have a two function. So which function help us to convert liter into gallon? G of x, right? So G of x, so if we just read that last statement, the conversion from liter to gallon is given by G of x. Okay, so G of x give us, it help us to convert liter into gallon. So we want to convert 10 liter into gallon. Okay, so our input x is 10. So 0.26 times 10. So that is 2.6 gallon. Okay, so 10 liter is 2.6 gallon. Now, this C composite G of x. So this C composite G of x, it gives us the cost of a fuel, okay, for running a vehicle if we have our fuel in a liter. Okay, so let's say we have a 10 liter of fuel. Now, what will be a cost of running a vehicle for that 10 liter of fuel? And that is given by this composite function. Okay, you replace x by 10, so 0.65 times 10, that is 6.5. Okay. Now in number part B, we are asked to find the cost of 120 liters of a fuel. Okay. Now we are asked to find cost of 100 liters of a fuel, and that is given by which function? So we have a three function now. So we have a C of x, we have a G of x, we have a C composite G. So which function give us cost of 120 liters of fuel? So why this is not C of x? Is it C of x or not? Why not C of x? Because our x in a C of x is a gallon, right? But we are given liter. Why not G? Because G, it convert liter into gallon. It does not help us to find the cost. Okay, but here we have a C composite G of x, and this function help us to find the cost when our fuel is in liter. Okay, so we will find C composite G. So it means we are asked to find C composite G of 120. Now how do we find C composite G of 120? Which function do we take here? We take C composite G function, and C composite G is 0.65x. You replace x of this expression by 120. So we have 0.65 times 120, and this is equals to $78. So it has to be in Canadian dollar. Okay, so this is how we can use our composite function. Okay, any question up to here? So let me know if you have any question. Yes. Now we have one more problem from this section. Is it from this section or the last section? Page 18. Okay. Now let's go back to page 18. Okay. Okay, now let's go to page 18. In page 18, okay, so here we still have this part B. We have to find the difference quotient. Okay, so let me write down the function here. So can you read the function for me? F of t, right? Yeah, what
f of t equals to minus 4.9 t squared plus 100.
Plus 100, okay. And we are asked to find difference quotient.
Yeah.
How they define? F of, is it a plus h?
Yeah.
Okay, minus f of a
Yeah.
divided by h, right?
Yeah.
Okay. So this is page 18, okay, part B. So we have a f function. F of t is equals to negative 4.9 t squared plus 100. And we are asked to find this expression. And we call this expression a difference quotient, okay? Now, at first, let's find f of a plus h. Now, what is f of a plus h? We know f of t is negative 4.9 t squared plus 100. How do we find f of a plus h? We take a function f, you replace every t of that function by this expression, whatever we have in this parenthesis. Okay, you replace t by a plus h. So let's replace t by a plus h. So we have negative 4.9 as it is, negative 4.9 as it is, and this t, okay, we replace this t by this expression a plus h. So a plus h, and we t has a square, so this expression has a square plus 100. Okay, this is f of a plus h. Now we have a negative, so negative. Now what is f of a? How do we find f of a? It's very similar to f of a plus h. Now instead of t, what do we write down? We replace t by, what do we have in the parenthesis? We have a, right? So we replace this t by a. Make sure you have parenthesis, negative 4.9 as it is. For this t, we have a, it has a square, plus 100 divided by h. Okay, this is the key step. Okay, if this is correct, the rest is simplifying. Okay, any question for this part here? You have to replace by whatever we have in the parenthesis. Okay, so here we had a plus h, so we replace t by a plus h. The rest is same. Okay, in order to find f of a, we replace t by a. Everything is same. Now let's simplify this. We have a plus h square, and what is that? So a plus h square. So this is a plus h times a plus h, right? So we use a FOIL, a times a, that is a square, a times h, that is ah, h times a, that is ah, h times h, that is h square. So this is a square plus 2ah plus h square. Now let's replace that. So here we have negative 4.9 as it is. For this we know this is a square plus 2ah plus h square plus 100, parenthesis, plus 100, minus, now let's distribute this negative for each term. So negative times negative 4.9a square, that is positive 4.9a square. Then we have negative 100 divided by h. Now let's distribute negative 4.9. Okay, we distribute negative 4.9 for a square, 2ah, and h square. So this is negative 4.9 a square, negative, okay, negative 4.9 times 2. Is it 9.8? 9.8 h negative 4.9 h square. Okay, now this 100 and this 100 is gone, plus 4.9 a square divided by h. Okay, now this and this is gone, so here we have negative 9.8 ah negative 4.9 h square divided by h. Now do not cancel h here. Okay, now how do we do that? We factor out h. Okay, so let's factor out h from numerator. Okay, so we have a h common here, and if you factor out h from negative 9.8 ah, we have negative 9.a negative 4.9 h divided by h. Now our numerator, so this is one expression, this is another expression. In between these two expressions we have a product. Okay, now we can cancel this h and this h, so the remaining expression is our final answer. So negative 9.8a minus 4.9h. So this is the difference quotient for a given f function.